Hi, Assalamualaikum. My name is Siti Imelda Maira binti Yusrizal. I'm going to explain about the introduction of humidification. Humidification is the process of increasing atmospheric humidity to ensure comfort, health, and industrial activities. It reduces dry skin, respiratory irritation, and static electricity. Humidifier, vaporizer, and steam generators all help to achieve this. It's critical in dry areas and colder seasons, and sectors like pharmaceuticals, textiles, and electronic rely on precise humidity regulation to ensure the product quality and industrial efficiency.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurlela Shafia binti Azahad and my matrix number is AA221835. So for this part, I will explain how to interpret the psychometric charge for humidifications. First of all, what we need to do is understanding the chart. As you can see here, I will explain. First of all, it's the line first. As you can see here, the yellow line is stand for wet bulb temperature, and for the green lines it stand for dew point temperature, and for the another green line it stand for moisture quantity, and I think the gray lines it stand for water temperature, and for the pink lines it stand for percent RH, and lastly for the blue line stand for dry bulb temperature. First step to interpret a psychometric charge for humidification is we need to understanding the chart axis. The horizontal axis represents dry bulb temperature, and for the vertical axis represent humidity ratio or specific humidity. Step 2. Locate the dry bulb temperature. The scale will be in degree Fahrenheit or Celsius. Okay, next, for part 3, we need to locate the humidity ratio along the right vertical axis, or also known as mixing ratio. Okay, for step 4, the saturation curve may be found by finding charts topmost curve line, and if you process line intersect the saturation curve, it means you have reached 100% relative humidity. Okay, for next step, which is step 5, we need to locate the interior curve line, or each of line represent a certain level of relative humidity in percent. Okay, next for step 6, we need to locate the vapor pressure line, and then it's referred to as the partial pressure or water vapor. Is an important parameter on a psychometric chart, as you can see here. Next, for step 7, we need to locate the enthalpy, typically measured in units like kilojoule per kg or BTU per LB, or use a ruler and match the scales diagonally across the chart. Okay, for the last step, which is step 8, we need to locate the second wet bulb temperature, or expressed as degree Fahrenheit or degree Celsius. And lastly, although the wet bulb line close to the enthalpy line, they basically not parallel to each other, as you can see here. Right? They not parallel.
Problem based on humidity chart is dry bulb temperature, wet bulb temperature, relative humidity, absolute humidity, dew point temperature, specific volume, and also enthalpy. The chart based on graphical display of air-water vapor mixture properties. There are three problems associated. The first one, specific enthalpy, and then humid volume, and also relative humidity. For problem solving, 100 milliliter humid air per minute enters a heater at 20 Celsius and 60% relative humidity. Use humidity chart to calculate the heat required to heat the air to 40 Celsius. The formula given is work done formula. Step 1, we are using the specific enthalpy formula, which is, as we can see, out minus in. For the in, as the shown calculation, 43 minus 0.15 equals to 42.85 kilojoule per kg, and for the out is 63 minus 0.7 equals to 62.3 kilojoule per kg. And using the specific enthalpy formula, 62.3 kilojoule per kg minus 42.85 kilojoule per kg equals to 19.45 kilojoule per kg. So for the step 2, we are using specific volume formula. As we can see at the equation, we are using 100 over 0.85, and then we're going to get 119 kilojoule per. Lastly, for the step 3 is energy balance. We are using specific enthalpy times specific volume. Then we're going to get 2315 kilojoule per mass per rate.